Hi, I'm Daric Gill. I'm a painter, sculptor, and I make robotic installations. Today, I'm going to show you how I made the translation machine. It's a motion-sensitive sound sculpture that's sonar reactive and a co-creation with honeybees. When triggered by motion, the sculpture plays recordings taken from my global travels. The closer you get to it, the louder the sounds become. This is achieved by using a microcontroller I programmed, a passive infrared sensor, and some sonar sensors. This is a long format video showing you the entire build process from start to finish. I'm going to show you how I designed each section in CAD, all the time I spent in the woodshop, how I connected with the honeybees, show you how I programmed and wired up all the electronics, and bring you along with me as I record things from around the world. And in the process, I'll explain why my head is in a beehive. Since this covers so many areas of the build process, I'm adding timestamps to the different phases of this project in the description below. And you can always skip to the end to see the final piece. First, I designed everything in Fusion 360. It's a 3D software program that allows me to add dimensions to each one of my designs. There's a couple reasons why I do this. First, I'm building this in 3 stages. The top part, the amplification cones, will live in the beehives while I build the acoustic tubes and the electronics in the shop. Secondly, I need to be very accurate with all the electronics that are going into it. And third, there's just so many angles in this. Of course, turning the computer drawings into real life requires woodworking. Let's start with the amplification cones. I need to build this first because it's going in the beehive for the summer. Most of the materials in this project are reclaimed. This includes the main material, which is about 100-something-year-old barnwood. I've got heaps of this stuff piled in a barn belonging to my family. I'm not sure if this has lead-based paint, but just to be safe, I'm wearing a respirator and sanding this off in a vacuum table. This keeps the dust particles down, out of the air, and hopefully out of everybody's lungs. Likewise, I knew that bees were going to be living in this, so I didn't want to embed the fibers of the wood with paint stripper. Now that I have the majority of the paint off, I can run magnets over it to make sure that there are no nails or any kind of metal inside of it. At this stage, I need to prepare the wood to be the right thickness, height, and width for the rest of the project. This starts by running it through the planer. Basically, a series of knives shave thin layers off the wood to make it a uniform thickness, and it creates 2 flat parallel surfaces. Once I have one side that's flat, I can go ahead and flip it over and run it through the machine again. This allows me to have both sides parallel to each other. But while the top and bottom are parallel, the sides might not be at a 90-degree angle. That's what this machine is for. It's called a jointer. Here, I'm taking the freshly planed side and putting it along that tall fence. Under that half-moon shape is another set of knives, just like the planer. And since I'm referencing the vertical wall, the cut should be at a 90-degree angle. So when I'm gluing it up right here, there's not a lot of gaps in between each slat of wood. With a lot of these, I'm applying clamping pressure from the outside edges, right? But you'll also see me apply clamping pressure, pushing down on the top. This keeps the wood from springing or bowing in the center as it's being clamped from the sides. Once the glue is dried, I sand it a little bit to get the gunk off and to see what I'm working with. Now that I have the surface cleaned off, I think this is sassafras wood. It smells a little like oak when you cut it, but it's kind of soft. You can run your thumbnail along it and mar the surface. If you know what it is, let me know. Now that the wood is planed and joined and glued up, I can start running it through the table saw to create basically this stock that I'm going to build the rest of it out of. This wooden device here is called a crosscut sled. It's often used when you're doing a cut across the grain where the wood is wider than it is long. It helps me ensure that I'm not binding the wood between the table saw fence and the blade. If you remember correctly, the amplification cones have 6 sides each, and there's 2 of those amplification cones. So I need to make at least 12 of these staves or panels to create the different size of the amplification cones. Each stave meets at a specific angle. These are called beveled miters. It's also a tapered stave, meaning that it's fat on the top and skinny at the bottom. Since I was designing this in 3D software, I could actually create parameters that I could change on the fly. I wasn't sure exactly how tall the bee boxes were when I was designing this, so I could change the height anytime I wanted to. And I wasn't sure how wide the wood was going to be, so I could change the thickness too. Creating compound angles like this requires a lot of math. You should pause it if you're interested. It's kind of crazy. One thing you might not know is a project like this often requires specialized jigs that are handmade. I kinda lost track of how many jigs I made, so I'm going to keep track of it in the video. Here I'm cutting those beveled edges that I showed you earlier and the taper all at once. This jig is basically a sacrificial fence or a scrap piece of wood screwed to the miter gauge, and a stop block with a beveled edge that cradles the piece I'm working with. Here's the first dry fit I'm putting together with just blue tape. Seems like the math worked. So each stave also gets this internal bevel. It'll make more sense later, but basically a speaker is going to sit inside this tapered edge. So I made another scrap wood jig, this time a vertical one that slides over the fence on the table saw. This allows me to keep my hands out of the way as I'm getting a vertical cut along the bottom of each stave. The glue up process for these was a bit tricky, so you can see that I had to get creative on how I applied pressure in the right spots. Here's scrap jig number 3. This little guy is a reciprocal angle. Basically, I'm putting this on the drill press and I need to drill down at a specific angle, and that jig allows me to prop this up at the right angle. I didn't end up using all of these holes, but I knew that I was going to put dowel rods in some of these holes, so I definitely needed to have this done in advance. This is a good point to sand a little bit, takes the burrs off of where I drilled, and evens out the grain and gets rid of any glue that's still hanging out. Here I insert 3 dowels into each cone at a specific distance so they can hang their honeycomb from it. It's designed to leave room for bee space, or the gap the bees make so that they can move around freely and regulate the temperature in the nest. Now's a good time to introduce my good friend Luke Howard at the Bee Collective. Here he's transferring a swarm of bees into the hive that I'm going to be using. He's the founder of the Bee Collective, a really cool organization that's dedicated to supporting pollinators through outreach, education, habitat establishment, and art. For this project, I partnered up with him and Dr. Sarah Scott, an entomologist and research scientist at Newcastle University. She's working to understand the drivers of bee decline and improving wild bee welfare. This sculpture hopes to get people more interested in globally minded concepts. It discusses the oscillation between purpose and compromise, in which different ecosystems are presented with an opportunity to blend through adaptive problem solving. For now, the honeybees know what they need to do, so I'm going to leave it in there for the summer. While the bees were doing their thing with the amplification cones, I needed to switch gears and work on the central electronics housing. Packed into this is the motion sensor and sonar sensor that I talked about, an Arduino Uno, an MP3 player that's programmable, an amplifier, and a power converter. First up is constructing the wood housing. Similarly to the amplification cones, this will have 6 sides as well, but I'm not going to taper it. I ended up making more than I needed just in case there was an issue in the future. You saw in the CAD drawing that there's a clear plexiglass window on both sides of this. Here I'm cutting the lip that plexiglass fits into. You can create a lip like this in a bunch of different ways. I'm using the table saw to just make a ton of passes. When you make that many passes on the table saw, it creates this kind of tooth on the lip. So here I'm just sanding each one of these down to make it nice and smooth. I'm using this long piece of wood as a straight edge, and this tape allows me to roll it up when I glue it. I'm a huge fan of belt clamps. There's tons of expensive products that are used to do stuff like this, but ultimately I think I got these like 20 years ago and they work just fine. Now I need to let this dry and come back to sand it in a second. I already scraped off the bulk of the dry glue with the razor blade, so now it's time to use my trusty Festool to sand it down proper, followed by a quick hand sanding. Next up are the terminal plates where I connect the audio wires from the speaker to the central housing. Mirrored acrylic is turned upside down to protect the lens and cut on the laser cutter. The speaker wires will connect to this central housing using binding posts, and they require a fairly large diameter hole, so I use a Forstner bit to cut out the large holes on either side. And of course there's all kinds of bolts that need to be screwed into this, so I drill the holes for those as well. So this looks like jig number 4, again made with scrap materials. This jig is used so that I can trace an outline using the router to make a recessed spot for the plate to fit into. All of this work is just purely for aesthetic value. Creating flush-mounted plates like this is a ton of work, but it looks a lot nicer. One of the really nice things about designing this in CAD software first is that I have the ability to know exactly where each component is going to go into this, down to where the power converter is located and the rubber feet, and right here I'm drilling holes where the electricity and the power switch are located. This gets another jig so that I can recess this panel in as well. I know it looks funky, but it's getting the job done and not wasting any materials in the process. The router causes a little bit of splintering on the edges, so I'm just knocking those down with the sander again. The construction of the housing is pretty much done, so now it's time to give it a couple coats of clear satin lacquer. This is really just a protective finish to keep things like dirt and dust off of it, and it gets lightly sanded in between each coat. Okay, so now it's time to laser cut out the face and the back plate. Another one of my projects was installed in a museum a couple years back, and during the deinstall there was a section that got cracked. It was an easy fix and I was able to keep the scraps. There was just enough left after the broken bits came off to allow me to get the front and the back panels for this project. All the electronics on the inside of this need mounting plates as well. So I'm using this acrylic and some of the mirrored acrylic to make those. The sonar sensor had its own issue. Its mounting holes were so tiny, so I decided it would be better to make my own mounting bracket for it. Now it's time to switch gears completely. I need to wire it up, program it, and fit it into the housing. In keeping with the motto of this project, I thought it was important to use both new equipment and stuff that's been kicking around my studio for a while. I'm programming all the main operations on an Arduino Uno. It's partnered up with a SparkFun MP3 Shield that stores all the sounds on it. The audio amplifier gets mounted to this clear acrylic base. The amplifier is obviously used to take the sounds coming from the MP3 Shield and make them stronger. Now I'm attaching the Arduino and the MP3 Shield. Next up, I'm installing the binding posts that fit into those flush-mounted panels that I made earlier. Now it's time to install the Ultrasonic Distance sensor, or the sonar sensor as it's commonly called. Here I'm using a mini wrench instead of a micro socket set, and it's giving me some problems. Alright, the passive infrared sensor, or the motion sensor, now gets installed right below it. And yes, I know it looks like a face. That was on purpose. I'm installing rubber feet on all 3 of the components in this. My hope is that it keeps all the vibrations to a minimum. Pretty often when you're building something like this, components might need different levels of voltage. So I'm installing a DC buck converter for some parts that step down the voltage. And of course, I've made friends with soldering after many years of doing this. After a quick voltage check, it's time to start installing the audio wire. It's a tight fit, so I'm routing the audio wires from the binding posts along the top. Arguably one of the more finicky parts of this process is creating aesthetically pleasing looking wiring harnesses that take these tiny wires and feed them to the terminal blocks in the Arduino. Most of these are communication wires that send data back and forth from the brain, which is this part, to the sensors that are mounted on the front faceplate. After a little bit of cleanup to get the fingerprints off, I'm attaching the brain part to the amplifier panel. It'll create this nice little electronics sandwich. Once those are together, it's time to start soldering up the power switch. I'm using these metal clips that came with the speakers to mount the electronics to the inside of the housing. Now I'm connecting power to the rest of the panels. Sometimes the best solution for connections are these Wago connectors. They're simple, they have little pull tabs that make the connection super easy, and I really love them. I'm reinforcing the audio wires with some solder so they make a nice solid connection to the terminals. And here I'm making connectors that attach to the sensors. With everything wired up and stuffed on the inside of this, it's time to screw down the faceplate to see if everything works. So there was in fact a problem. Somewhere along the line, I forgot a ground connection. So I need to take the wiring harness out that I made and create a new one. This is one of those circumstances where you try to figure out the problem for a while and it takes forever. But once you find the problem, you kick yourself because it's so simple. With that done, I can start working on the acoustic tubes. After doing some acoustic calculations, I decided not to do this bend here. One cut in each tube would be complicated enough, and I didn't want to risk losing all of this wood. For everything to match up correctly, each bevel has to be exactly 30 degrees. To start, I'm going to cut bevels just like I did with the electronics housing, but this time I'm going to use longer slats. As I'm cutting these, I'm deciding that I'm not going to use that macaroni type shape in the acoustic tubes, and instead lean into the long-stemmed flower that it originally was supposed to look like, if that makes sense. And just like before, I'm using tape to line everything up. The goal is to roll it up like we saw before and use strap clamps to hold everything tightly together. At this point, I knew the blue tape wasn't going to work, but I kept plugging away for some reason. It's a totally rookie move, but hey, sometimes you get that way. The funny thing is, I had much stronger tape about 15 feet away in my bag. After I was sufficiently covered in glue, I knew I needed to take this off camera, get my stronger tape, and do it the right way. From experience, I knew that I needed to make sure that 2 of the seams didn't have glue. This way I could strap it all together and it would apply even pressure, but I could break it back open and sand the edges flat. Any discrepancy in angles could be fixed at this point. Then, with the 2 halves totally flat, I can tape it together with this stronger tape and glue it back together. I like to use standard utility knife blades to scrape off the extra glue. Then I can go over it with the sander again. Before I start doing all the really complicated cuts, I need to create another jig that allows me to give a nice true 90-degree cut on the edge. I'm using a special saw called a Japanese flush cutting saw. It's sort of like a flat spatula and can rest right up on the template. It's time for another jig. Since the 90-degree angle jig worked, my original thought was to make a collar that was just like it at a different angle. It was pretty flexible, so I needed to glue up some supports. This was a couple pieces of walnut scraps from the CNC mill. Okay, the moment of truth. I need to cut a perfect slice, rotate it, and then reattach it, making sure that it fits back together like it never happened. I can tell that this template isn't going to work. It likes to shimmy down too much. Since I have 2 acoustic tubes, I'm going to try a different process on the second one. And that means, you guessed it, another jig. Since I have all the angles saved in the digital versions, why not use the laser cutter to create feet that are at the exact right angle? This feels a lot more stable, and I can glide the saw across the template easier. This is a really nerve-wracking part. If I make any big mistake at all, I could ruin months of work. It's pretty good, but I think I can do better. So I do another slice just to see if I can get exactly the right angle again. This time I can see that it is shimmying with just a tiny amount of air. For most uses this would be totally acceptable, but I know that this is going to go into museums and galleries. And since I'm going to be doing several of these cuts, each air will compound on itself. Since the laser cut supports work so well in stabilizing it, I'm going to make copies of them in wood. I'm using a special bit on the table router. The top bearing rides along the laser cut part and cuts duplicates out of the wood sandwich below it. Here you can see me pulling off the different layers and marking the angles. Okay, well, scrap jig number 9 wasn't any better. But the 10th jig worked just fine. There's a lot going on here, so I'm going to take some time to explain it. Basically, I built this box out of a couple of the jigs. Since I already cut the angle, all I need to do is reface it. You can see a little bit better from this angle how it works. The acoustic tubes slide into this box, with the angled part facing out. I have a router that's attached to a flat piece of wood, and that flat piece of wood just glides along the surface, and the cutter on the router can only go down so deep. Part of the tube is long and part of the tube is short. The short part can fit in the box while the long part sticks out. I'm using a weight here to keep things from getting away from me. You might have seen me pull up quarters here. That's a handy trick to get the depth always the same. As I mentioned before, I made this jig using several different jigs. I took apart the more complicated jig so I could make a 90-degree perpendicular cut for the ends. I remember thinking at this point that I felt like I was making 2 giant crazy straws. All that cutting and routering left a little bit of tool marking, so I need to do a little sanding by hand. Just like the electronics housing, I need to drill some holes for the binding posts where the audio wire will connect. This is a pretty tricky operation, so I'm going to take it slow and only go about halfway through, making sure to clamp it nice and tight to the bench. This also keeps the tear out from happening as much. And the process is the same for getting flush mounted panels in this as well. This time I updated the jig a little bit. While it's technically doing the same thing, it is jig number 11. The end grain in this can chip away pretty easily, so I'm filing it down before I go any further. Here I'm doing a couple final passes with the hand sanding. This is just to ensure that I have a nice fresh surface to glue up. Next, I need to dry fit it. This is a practical exercise. Because the two sides don't meet at a 90-degree angle, and the glue is pretty slippery, it's very likely that these two parts will slide away from each other. So I need to do a little bit of math to figure out exactly where the pressure needs to be placed and at what angle. And here's the moment of truth. Acoustic tube number 1 is glued up, and after a few realignments of the clamps, I just need to set it aside to dry. That was just the first acoustic tube to get glued up. I have to sand the second one and do the glue up again. This time I'm arranging the strap clamps in a little bit different area, and I'm going to use this really strong double stick tape to keep things aligned. You can see me playing with a couple different arrangements for the strap clamps. With a huge sigh of relief, I took off the strap clamps, and it looked great. There's very little glue leakage, so a simple sanding was really all that it needed. I'm getting in the cracks with some hand sandpaper and using the random orbital sander for the rest. And just like the rest of the parts, it gets a couple coats of clear lacquer. It wouldn't be complete without some rubber feet. And a little more hand sanding between layers of lacquer, just to make things look extra good. Between the amplification cone and the acoustic tube is a speaker. It gets a mounting plate as well. I had some excess white acrylic from a project I did quite a few years ago. Originally, I had designed some brackets to fit in those key-shaped slots. After some careful consideration, I decided on a simpler solution, but left the slots there just in case I needed them in the future. Each speaker is going to get mounted to a faceplate like this and recessed in the acoustic tube. And just like before, I'm going to create a jig to use with the router. This one looks exceptionally funky, but it works just fine. The bottom piece of plexi has a hole cut out of it in the shape that I want to trace, and those 6 pieces of wood are acting as registration to keep the bottom acrylic from moving around as I router around the template. Because the hole is pretty big and my router is pretty small, I need to essentially extend the base of my router. That's why the scrap piece of acrylic is attached to the router as well. After one more pass, it's getting the green light and the go-ahead. I pulled these marine grade speakers off of another sculpture. Even though the bees have already taken all the honey out of the combs, I knew that there would be some excess dripping onto the speakers. I figured that if they were waterproof, they were probably honeyproof as well. I'm sure the people at Kicker Audio never thought their boat speakers would be used on a honeycomb sculpture. Even though I had been designing this for months, I still hadn't figured out how I was going to connect the bottom half to the top half. For transportation and protection, the top part needed to be removable. For weeks I pored over hooks and latches and different type of mechanisms to pinch together 2 objects. And after being inspired by cabbage cases, I decided to go with these toggle latch clamps. After a few months, it's time to take the pieces out of the hives. Our beekeeper friend Luke is using a pine smoker to subdue the bees, because in a minute I'm going to be sticking my head into this, but more on that in a second. Now that the amplification cones are out of the hives, I need to scrape off the excess honeycomb and the propolis. Now propolis is a really interesting thing. It's a really strong resin that the bees make using the wax and organic materials from their surroundings. They use it to fill up gaps and holes and seal off different areas of the hive. It's so strong, sometimes you need a crowbar to pull things apart. This is a really important moment. Remember, the top halves have been in a hive for the last few months, and I made the bottom part separately. This is really the first time I get to see them put together with the speakers and everything attached. At this point, I'm not even sure if the toggle clamps are going to work. There's actually 3 of these clamps around the circumference that are clamped down to keep it firm. To my amazement, it worked beautifully. Next, I'm going to talk about the adventures in collecting sound. To get the full effect, it's best with headphones. I've always been an adventurous person, curious by nature. But it wasn't until my first artist residency in another country that I had enough time and space to fully understand what it felt like and sounded like to be a stranger in a strange land. I'm captivated by the many translations we do, the subtle changes we make to our tones or behaviors when we have an experience or an ecosystem that needs to blend with another. I'm fascinated with how those experiences can be archived, capturing it for later, recombining its elements, and sharing it with others. Here's how I did it for this piece. Over the years, I've used a few devices to capture sound. When I first started getting serious, I used a Zoom H1N field recorder. It's small enough to fit in my pocket, and it has 2 XY microphones that do a decent job capturing 3D audio. Here are some samples. It's not perfect though. It has a pretty high noise floor, and even though you're supposed to hold it in your hand, the slightest change in grip is super loud. All of this has to be edited out in post. And if the situation is too loud, it's not much better than a brand new phone microphone. After doing some research, I wanted to try out the binaural microphones by Sonic Presence. So what are binaural microphones? Imagine you're in a room and your friends start singing. One of your ears will pick up the sound just a little bit faster than the other, and your head itself will block some of the sound as well. If you recorded them with one stationary microphone, you may get a different volume based on where you put that microphone. And if you used 2 microphones placed on either side of your head, you would get a recording that would mimic exactly what your ears hear. They look like headphones, but they don't play noise, they record noise, and windscreens prevent windy distractions. This is the reason my head is in a beehive. I'm wearing 2 microphones on my ears. See if you can hear a difference.
Sono parlando adesso non ci credo che mangiare
Now I need to edit all of the sounds in Adobe Audition. Here I can look at all the different sound frequencies and edit out the frequencies I don't want. The final step is to load all the different sounds on an SD card and program the brain, which is an Arduino, to talk to the different sensors that perform the different actions. And here is the final result.
This is what it sounds like to walk through tunnels burrowed through a glacier. The turquoise ice drips streams of water as the glacier melts. Voices can be heard echoing through the ice cave as people are taught about climate change. Mer de Glace, Chamonix, France.